everyone and welcome to my channel. This video, my topic is transformations and the subtopic is rotations. I'm going to cover matrix method as well as graphical method, and also I hope to include a question where we have to find the center of rotation and so on. In this topic is really covered in Form 4, Form 5 and Form Maths. So please stay tuned to see what I have in store. What is a rotation? A rotation is simply the movement of an object in a particular direction using a particular center for the rotation, and it goes under a new position, but nothing happens to the object. The object does not change the shape of it, right? For instance, if it was a square, it will remain as a square. It will not change into a rectangle and so on. In math, this is required information for rotations. You must have an angle of rotation, a center of rotation, and a direction for which your rotation is going to take place. This direction could be clockwise or anti-clockwise. The angle could be 90 degrees, 30 degrees, anything, and the center of rotation is just a coordinate. In math, once again, a rotation can be done using two methods. There's the matrix method and the graphical method. As I mentioned earlier, a rotation requires three pieces of information: the center of rotation, the angle, and the direction. Here I have, for matrix method, a host of various matrices that we use. If the rotation is 90 degrees, it is clockwise, and the center of rotation is the origin, that is 0, 0, then this is the matrix that we'll use, 0, 1, minus 1, 0. If it's 90 degrees and it's counterclockwise or anti-clockwise, then this is the matrix that we'll use. All of these are for the center of rotation being the origin, which is 0, 0. Now, these are the steps we need to use in order to use matrix method. We have to assess which matrix we need to use for the rotation. So that is, say we choose one of these here, and then we multiply this matrix by the coordinates you are rotating, but you must put these coordinates vertically. Reading vertically, these are the image points of the rotation, meaning once we have multiplied, then we read vertically again and we will get the image points of the rotation. If, however, the angle that we want to rotate our object by is not given here, meaning it's not 90, 180 or 270 degrees, and say it's something else, say it was 30 degrees, then we could create a matrix for this. We could actually insert 30 degrees here in all these spots and get a new matrix, and that would actually give us a matrix like this. Now, how I got these values was simply putting in 30 degrees here using my calculator on the degree function and creating this matrix here. Now, I would use this matrix in these steps. Now, of course, I plan to go through an example to show you exactly how this is done. The second method I want to go through here in notes is the graphical method. The first step is we draw a line connecting the point we are rotating and the center of rotation. We measure the angle of rotation from this line, making sure to follow the direction required. We mark off this point and draw a line connecting the center of rotation and the mark from the protractor. Measure the length of the line from the center to the first point, and then we measure it and so on. Now let me go through a worked example. Example 1. Say I had to rotate these points 90 degrees anti-clockwise from the origin. Now let me start to see how I would do this one using the matrix method firstly. Now, these are the steps in using the matrix method, but before I get into that, I need to plot these 3 points here. So let me plot these points and then I'll continue. Now I have these 3 points and I need to follow these steps. Assess which matrix we're going to use for this rotation. Now it's 90 degrees, it's anti-clockwise, and it's from the origin. So that matrix will actually be 0, minus 1, 1, 0. So I've completed this step. Next, I'm going to multiply this matrix by the coordinates you are rotating, but put the coordinates vertically, meaning I'm going to multiply it this way. I'm going to put A, B, and C, and I'm going to state them vertically instead of horizontally like this. So this is what it's going to be. Then I'm going to multiply, and this is going to create A dash, B dash, and C dash, again vertically. Answers for this, multiplying row by column, this is a 2 by 2 matrix, multiplying by a 2 by 3 matrix will create another 2 by 3, will be So now I have my coordinates for A dash, B dash, C dash, and I could just simply plot this. Plotting the points, I get this, and now we can see that this is simply really a rotation. I took this black triangle, rotated it 90 degrees this way, and I created this green triangle here with A dash, B dash, C dash, right? Now one thing we can note too, when we're rotating 90 degrees anti-clockwise, if the coordinates are say 1 and 2, the answer, the image points ends up being -2, 1. So we simply swap the values and we change the sign of the y coordinate. That's what we did here. Now let me do the same thing but using the graphical method. Using the graphical method now with the same example 1, again I plot my triangle, so I get this ABC, and I have to identify some stuff. 90 degrees is my angle, anti-clockwise is my direction, and the origin is my center of rotation. So the first point says draw a line connecting a point we're rotating and the center of rotation. So let's locate the center. The center is the origin. So I will simply use any point. I could use, well, I would just go with A. So I will draw a line connecting this center and A. So this means that this first point is completed. And the second thing I would do, that's creating this green line, right? I would measure the angle of rotation from this line, making sure to follow the direction marked required, right? The angle is 90 degrees. So I have to take a protractor now and place it over here, making this center of rotation match with my center of the protractor. Please excuse my little drawing, but I'm trying to create a protractor here. And I will set it like this with the center here on this point, and I will measure 90 degrees. So it will be around here. So now they say off this point and draw a line connecting the center of rotation and the marker from the protractor. So this is my marker here to indicate 90 degrees, meaning 90 degrees made here, right? Like that. So this marker here now, I am going to draw a line connecting this center of rotation to this red marker here. So you may have a line looking something like my red line here, right? Now from this point now, we're going to measure the length of the line from the center of rotation to the first point. So I'm going to use some highlighters here. I'm going to measure this distance here from the center of rotation to the first point, which is A. And I'm going to measure the same, so I did that, measure the same distance as point 3 along the new marked off line, right? So I'm going to measure that same distance along this red line. So say it will be around this distance here if I measure it, right? Now, at the end of this measurement now, I am going to create the image point of the point that I have started off with, which is A, right? So the point is A, so the image point will be A dash. So I'm going to do that now. So here's now A dash, which is -2, 1, or is a little above actually, and this may happen too with using the graphical method, right, with rotations. So what will happen is that you may be off by a little bit because it's construction you're really doing, right? Now what you can do is when you're finished, you mark off your point here darker, and then you repeat the process for all the points. So this is just the work for point A, right? Now if you notice as well, there's a 90 degree here that we could kind of see for ourselves, right? We're going to repeat this for point B and point C. So repeating this process now, I'm going to draw a straight line from the center now to B, take my protractor, and I'm going to create the 90 degree marker. Placing my protractor over here now, with making a 90 degree angle with the green line and the center of rotation. My marker might come across something like this, say up here, right? So that's about there. So, and now I'm going to extend that line. As I said earlier, I'm repeating the step. So I did this, I did this. Now I'm going to measure the line now. So let me measure with another color. So I'm measuring this distance here, right? Whatever distance that is, I'm going to go along this new line now and measure the same distance. And the end point now, I'm going to make that B dash. So now I have 2 points, and again I repeat for the third point, and I will get my C dash. Now I have repeated the process now for C and C dash and created this point here. So I have a new triangle now called, well, a red triangle, which is the image. So this is the object and this is the image. Now if you notice, my A dash point is not exactly where it should be. It should be lower down here, but because of construction lines and also because I'm doing this on the computer, I would not do it as accurately as you all when you all are doing it with your graph people, right? Of course, when you're doing a graphical method, make sure to leave all those construction lines, the lines that I took off, connecting A and A dash, B and B dash, and so on. You can leave all those. So this, everyone, is the solution for how to construct, well, do a rotation using the graphical method. Now I want to go on to one more example where I give you an object and an image, and then I ask you to find the center of rotation, the angle of rotation, and the direction. Example 2. Now in this example, they give us points K, L, M. They say it undergoes a rotation, and it creates K dash, L dash, M dash. We need to find the angle of rotation, the center of rotation, and the direction of the rotation. So now let's begin. Now the first thing you need to do is draw up your graph, right? And you need to create these points K, L, and M, and K dash, L dash, and M dash. I'm going to do that now. Putting these points on our graph paper, we get this. We get the black triangle being the object, and the red triangle is the image. Now let me see what are the steps. Graphical method, the first step is to draw a line connecting the point and its image. So we're going to do this with each one, right? So I'm going to start with, say, K and K dash. I'm going to draw a straight line to connect these two. Then I'm going to bisect this line using a compass. In doing point 1, I created this blue line here connecting K and K dash. To bisect this using a compass, now if anyone has forgotten, what we need to do is we need to place a compass here where the point is here, meaning the needle is here on the K, and then you're going to open out your compass where the pencil is on this side, and you're opening it out a little more than half of this blue line, right? And you're going to scribe above and below, right? Now you're going to keep that same width that you have for the compass that you placed here on K, and you are going to repeat this process and put it on K dash. The needle is going to come here, and the pencil is going to remain for whatever width it was open for when it was on K, and you're scribing above and below. Now you should see that your scribes from K and your scribes from K dash are intersecting to create some sort of X's. If they're not, just simply go back to K and extend your scribe, your top and bottom, and go back to K dash and do the same, and they should meet at some point. Now this point here where the two meet, these X's are created. I'm going to create a line that will go through these X's, and what that is actually doing, it is actually cutting this blue line in half, right, exactly in the midpoint there at 90 degrees. So that line that I'm going to create there is going to be called the perpendicular bisector. Creating a line that will go through these X's as best as I can, right, is creating a perpendicular bisector. So this pink line, everyone, is the perpendicular bisector to the line K dash, the blue line, right? Perpendicular bisector simply means it's a line that is perpendicular to the original line, and it cuts or it bisects the line. So meaning it cuts in half or it passes through the midpoint, right? Now I have to repeat the same steps here, these same steps. Again, they say repeat for another pair of points. So I did it for K and K dash. Now let me repeat for two others. So as I said, I'm going to repeat these steps here for, well, two other points. I'm going to do it for M and M dash. M dash is here, this red point here, and M is there. So I'm going to create a line there. Say something like that. Then I'm going to bisect. So again, I'm going to place the needle here on M dash, needle, open it out a little more than half, and scribe above and below, right? Then placing needle on M, keep the same width that I had, scribe above and below, and simply connect these two. My scribes go a little bit off there because I'm doing it on the computer, so I change it, right? So the scribes are now around here, and then I'm going to create this line that will go through the scribes, right? Now this yellow line is actually, or orange line is actually perpendicular to this other line here, right? The line M dash. So again, this line here is the perpendicular bisector to M dash. Now what happens here is that this pink line and this orange line meet at this point. So this point, guys, is your center of rotation. So everybody, we can see the center of rotation is 1, 4, right? So we're going to create that point, And then they say where the two perpendicular bisector lines meet, this would be the center of rotation. Nice, done. To get the angle of rotation, we must measure the angle between the point and its image, where they are connected by these lines. So all these lines that we have to leave them, right? We can't take them out. So now let me try to figure out what is the angle of rotation. So again, let's say this is my center. I will now draw a line connecting, say, M and the center, like this, a kind of burgundy line. And I'm going to draw another line and connect the center with, what's that? M dashes here, yeah. And I'm going to measure this angle here, guys, this angle here, right? Now this angle is 90 degrees. If I go, this is M here, this is the start and this is the end, right? So I use the word start and end because the original shape was KLM, right? This was the original shape and it became this red shape here. So the start is M, this line here, and it came to M dash. So we can say that it went 90 degrees in this direction, which is clockwise. So it's a 90 degrees clockwise rotation about the point, what's that, 1 minus 4, sorry 1 4, right? Because that's the point here, center of rotation, that I found out about a minute ago. Or if we looked at it in the other direction, so we looked at it going this way instead, which is an anti-clockwise direction, then it will be 270 degrees anti-clockwise, right, with the same 1 4 center of rotation. So either answer is correct. It all depends on how you look at it, right? So whichever answer you state would be correct, right? Unless if they say they want the clockwise rotation also, it doesn't matter, right? So now everyone, this takes me to the end of my video. I hope that you all understand what I did. We went through all the various ways that there are to do a rotation, as well as the graphical method. And lastly, I worked out how to find the center of rotation, angle of rotation, and the direction of rotation given two shapes, right? So please, thank you for staying tuned, and please feel free to like, share, and subscribe.